Example 20. The angle of elevation of the sun is 27 degrees. Find the length of a shadow cast by a tree that is 47 feet tall. Round answer to 2 decimal places. So we have our tree. It's casting a shadow. Remember, when we see shadows, they're on the ground. So this length here, that is the length of the shadow. We have a 40-degree angle here. The angle of elevation, whenever we're doing angle of elevation with these types of problems, that angle is not going to be above the 90-degree symbol. It's going to be away from the 90 degree. So this angle over here, that's 27 degrees. Let's see, the tree is 47 feet tall. Find the length of the shadow. So this is what we're trying to solve for here. So we have our angle. We have an opposite side. We have an adjacent side. So we're going to use tangent because that's the one where we would use opposite and adjacent. Tangent 27 degrees is equal to opposite over adjacent. Multiply both sides by x. And then divide both sides by tangent 27. You would need a calculator here. Make sure you're using the fraction symbol. You want the numerator to be 47 and the denominator to be tangent of 27. Does it tell us where to round? Round answer to 2 decimal places. So the length of the shadow would be 92.24 feet. Example 21, 2 times sine of x minus 1 equals 0. Get used to looking at the type of problem that they're giving you so that you can have a familiarity with the pattern that it would take to solve. Whenever we're having a trig equation like this, you're going to want to add 1 versus both sides. Then divide both sides by 2. And now what we're trying to figure out is, in our unit circle, what radians have a sine value of 1/2? You're going to have 2 answers for this one. So we know that sine is positive in quadrants 1 and 2. And the radians where sine is positive 1/2 are here at 5 pi over 6 and here at pi over 6. So those are our 2 answers. Those are the radians that have a sine value of positive 1/2. We're now going to factor example 22a. In order to factor a trinomial, you multiply the number in front by the number in back. So we're multiplying 1 times 3. Create a t-chart. The factors of 3 are 1 and 3. They must add to get -4. So both of these are going to be negative. And now we can substitute x squared. I'm going to substitute my factors, but give them x. And you can tell you factored correctly if this still matches that. So x squared is still x squared. Negative x minus 3x combined to get negative 4x, and 3 is still 3. Now we're going to see what can we factor out by grouping. This group has x in common, so we could factor out an x, and that would leave us with x minus 1. This group, we could factor out a negative 3, and that would leave us with x minus 1 again. Before you move on, you can check, did I factor correctly by taking this x and distributing it throughout the parentheses? And if you factored correctly, if you distribute throughout the parentheses, you would end up with what we originally had before we factored out by grouping. So x times x is x squared. X times negative 1 is negative 1x. So we're on the right track. Final answer is going to be in 2 sets of parentheses. This outside set of terms is going to be in one of our parentheses, so x minus 3. And then we need to keep one set of the matching parentheses. And that is your answer. We're going to multiply 10 times negative 3 to get, ran out of room, sorry, to get negative 30. Be careful with terms like this. So the factors of 30 or negative 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now we have 2 factors here, 2 sets of factors that can one way or another get to 13. But you have to take into account that symbol there. That symbol there is minus. So what that means is our factors must subtract to get to 13 or negative 13. So that eliminates 3 and 10. Because yes, those add to get 13, but our factors have to subtract to get 13. So we need 2 and 15 here. We're going to have different symbols. This symbol tells us the minus is going to go to the biggest factor. I'm going to do some erasing here so I can give myself some room. So those factors, once again, were 2 and 15. 15 was negative. The 2 has to be positive in this case. And now we can create our grouping problem. Out of here, we could factor out a 2x. That would leave us with 5x plus 1. Here we could factor out a negative 3, leaving us with 5x plus 1 again. Keep your outside terms. And only one set of inside matching terms. That's your answer. Let's start factoring 21c. 3 times negative 8. We have the factors of, we need factors of negative 24 that subtract to get 10. So we need 2 and 12. Different signs. This time, the biggest number gets the addition symbol. Now we can group. Out of that group, we could factor out an x, leaving us with 3x minus 2. Out of this group, looks like we could factor out a positive 4, leaving us with 3x minus 2 again. For example D, if you're able to recognize your perfect squares very quickly, these are simple to factor. 4 is a perfect squared, as is x squared, as is 1. They must be separated by a minus sign in order to factor a difference of perfect squares. So you just need two sets of parentheses, give them different symbols, take the square root of the first term, which would be 2x, and write the result in the front of each set of parentheses. Then take the square root of the last term and write that result in the ending portion of the parentheses. And you're done. For section 23, these are a difference or sum of perfect cubes. We have x cubed minus 8. This is not as easy as factoring difference of perfect squares, but can be very, very easy as long as you're committed to memorizing the pattern of how to solve these. First, you want to start with the acronym SOAP. That is going to help us with our signs. So our sign has to be, this sign here has to be the same as in the original problem. This next sign has to be opposite of the given problem. And then this last sign will always be positive. Make sure and take care of that step first. Now, in order to fill in this gap here, you're going to take the cube root of the first term, which would be x. In order to fill in this gap here, you're going to take the cube root of the last term, which would be 2. This is part A. This is part B. In order to fill in the remainder of the gaps, here's what you're going to do. We're going to take our A term, which is x, and square it. We're going to take our A and B terms and multiply them. So x times 2. We're then going to take our B term and square it. Our B term is 2. If we were to square that, we would get 4. And then the information that we have written in parentheses is the final answer. Example 23b, factoring a difference of perfect, or I'm sorry, this time we're factoring a sum of perfect cubes. Now, unlike perfect squares, you can factor perfect cubes whether or not there is a minus or addition sign separating them. Two sets of parentheses. Let's do the acronym SOAP first. Same, opposite, always positive. The cube root of 8x cubed is 2x. The cube root of 27 is 3. In the event you don't know your perfect cubes, in the calculator, you would do, it's been a while, math. And then option 4 allows you to take a cube root of a number. You could plug in 27. And it tells us the cube root of 27 is 3. All right, so for this gap here, we're going to take our first term and square it. 2 squared is 4, and x squared is x squared. We're now going to multiply these two terms together. 2x times 3 is 6x. And then we're going to take this term here, 3, and square that to get 9. Final answer. Looking at example 23c, we have something in common that we can factor out first. So we would factor out a 2. That would leave us with x cubed minus 1. And what I have in parentheses here is now a difference of perfect squares. Make sure to keep the 2 that we factored out originally. Acronym SOAP, same, opposite, always positive. And now we start plugging away. Cube root of x cubed is x. Cube root of 1 is 1. And now we can fill in the remaining gaps. And that is your final answer. Example 24. Given A equals 54 degrees, B equals 80 degrees, and A equals 4.1, use the law of sines to solve the triangle for the value of B. Round answer to 2 decimal places. They have given us a diagram of a triangle. You can use this diagram if you want to. You can draw a triangle on your own. It doesn't matter as long as you follow that A is 54, B is 80 degrees, and side A is 4.1. As long as you're able to label those sides or those angles appropriately, it doesn't really matter what your triangle looks like. So angle A is 54 degrees. In my triangle, that would be here. Angle B is 80 degrees. My triangle, that would be here. And then side A is 4.1 units of measure. Here's angle A, so opposite of angle A is side A. They tell us to use the law of sines. I cannot guarantee you they're going to tell you which law that you need to use, but here's a little trick. If you will set up your information like this, angle A, angle B, angle C, side A, side B, side C, it makes it a little bit easier to figure out which law you're going to need to use. Now, they have told us that we are looking for the value of side B, so we're looking for this side here. You see how this row, we have 2 bits of information, and this row we have 1 bit and then another that we need to solve for? That right there is an indicator that you're going to want to use law of sines. So our law of sines is side A over sine of A is equal to side B over sine of B, which is equal to side C over sine of C. Well, since we have information for row A and half of the information for row B, I'm not going to worry about that particular portion of the equation. I'm just going to worry about this right here. So side A is 4.1 over sine of angle A, which is 54 degrees. We're going to set that equal to side B. We don't know what that is. I'm going to use an X for the variable over sine of B, which is 80 degrees. And now we're going to cross multiply. So 4.1 times sine of 80. Set that equal to X times sine of 45. I think I said 45. I meant 54, sorry. Now we can solve for X by dividing both sides by sine of 54. So X is going to equal whatever that is once we plug it into our calculator. So let's do that. Make sure you're using the fraction symbol here. Looks like 4.990. They wanted us to round to 2 decimal places. So side B is 4.99 units of measure. Example 25, given A equals 5, B equals 8, and C equals 9. Use the law of cosines to solve the triangle for the value of A. Side A, 5. Side B, 8, and side C, 9. They tell you to use law of cosines. I can't guarantee it's going to tell you exactly which law you're going to have to use on your final exam. But if you have 3 sides of a triangle and it tells you to solve for an angle, that's the law of cosines. You will not have to memorize these laws. There will be a formula chart that will be given to you. You're just going to have to know when to apply them. So we are solving for the measure of angle A. Here's the pattern. So cosine of angle A is equal to B squared plus C squared minus A squared all over 2 times B times C. So I'm going to start plugging in my data now. Now, remember, we're about to solve for an angle. We don't know what the angle is. So in order to do that, we have to use inverse of cosine. And whenever we use inverse, the variable and your number, they're just going to switch sides. So all of this stuff that I have as a fraction, I'm going to substitute in parentheses. So this goes here, the a goes there. In the calculator, cosine or second cosine, let's do second cosine. Now the fraction symbol, alpha y equals enter, and then just start plugging in all of that stuff that we have written down. Where does it tell us to round in this problem? Round your answer to 2 decimal places. So angle A is 33.56 degrees.